Let's do some examples from the day 28 assignment. Here, they want us to show that this figure that we're looking at is a parallelogram. So they're going to guide us through this. We know that parallelograms have opposite sides that are congruent. It also has opposite sides that are parallel. So it looks like we're starting off by proving that opposite sides are parallel. They want the slope of KL. Well, K is at -2, -2. L is at the origin at 0, 0. So the slope would be -2 minus 0 over -2 minus 0, which is -2 over -2, which is 1. And Mn, M is at 2, -1, and N is at 0, -3. So the slope of that is -1 plus 3 over 2 minus 0, and that's going to be 2 over 2, which is 1. So both of those have a slope of 1. Now let's find the slope of LM. L is at 0, 0. M is at 2, -1. So the slope there would be 0 plus 1 over 0 minus 2. So the slope there is 1 over -2, which is -1/2. The slope of NK, N is at 0, -3. K is at -2, -2. So the slope there would be -3 plus 2 over 0 plus 2, which is -1 over 2, which is also -1/2. So there the slope is -1 over 2, -1 over 2. So the slope of KL is parallel to MN because they have the same slope, and LM is parallel to NK. Therefore, quadrilateral is a parallelogram because both pairs of opposite sides are parallel. Okay, find the coordinates of a missing vertex in the parallelogram. Use parentheses when entering the coordinates. So in order to make this a parallelogram, where would C have to be in order to make this be a parallelogram? Well, if opposite sides are parallel, then this C would have to be in a place where we would have where C would have to be somewhere here where it would be parallel to AD, and the same thing with CD. I would say the easiest way to do this is just use rise and run, just count. So like here from A to D, we're moving 1, 2 up and 1, 2 to the right. Just do the same thing over here, 1, 2 up and 1, 2 to the right. So point C would have to be at the origin. If I put that there, that would make this into a parallelogram. Show that this quadrilateral is a trapezoid, but is not a parallelogram. So in order to be a trapezoid, only the bases would be parallel. Well, I can tell that those two sides are parallel because they're both horizontal. So FG and J and HJ have a slope of 0. Feel free to use slope formula if you want, but I know that horizontal lines have a slope of 0. Now GH, see G is at 2, 2, and H is at 4, negative 1. So the slope there would be 2 plus 1 over 2 minus 4. So it's 3 over negative 2, which is negative 3 over 2. If JF would have the same slope, then it would have to be a parallelogram, because then they would have two sets of opposite sides that are parallel. So let's see, J is at negative 3, negative 1, and F is at negative 4, 2. So slope is going to be negative 1 minus 2 over negative 3 plus 4. So the slope is negative 3 over 1, which is negative 3. Since these two slopes are not the same, that means that this would be a trapezoid because there's only one pair of parallel sides. Has one pair. Determine whether the statement is always, sometimes, or never true and complete the explanation. A parallelogram with vertices at 0, 0, 2, 0, 0, 2, and at any point on the line y equals x. Okay, a parallelogram has vertices at 0, 0, 2, 0, 0, 2, and any point on y equals x. So this statement, let's see. If I were to just sketch a graph that's saying, so 0, 0, 2, 0, 0, 2, and then they're saying that any point on this line of y equals x would make that a parallelogram. That appears to not be true because a parallelogram has two sets of opposite sides that are parallel, and the only way that this would make this a parallelogram would be that other point would have to be at 2, 2, and then you'd have a parallelogram. What this looks more like would be a kite. Let's see. This statement it could sometimes be true, but only true at 2, 2. When the fourth vertex is a point on the line y equals x, the quadrilateral is not a parallelogram except for when the fourth vertex is at 2, 2. In this case, the quadrilateral is a parallelogram since two sides are horizontal and two sides are vertical. I think they mean if that other vertex was at 2, 2. So maybe that's not what they meant. In this case, the quadrilateral is a parallel since two sides are horizontal and two sides are vertical. Sometimes true. Except when the fourth vertex is 2, 2. In this case, the quadrilateral I don't know, maybe they're not talking about 2, 2, so I would say is not, and only because one side is horizontal and one side is vertical. The fourth vertex is at 1, 1. Is this quadrilateral a parallelogram? I don't even know where it says 1, 1. I'm not. It's a poorly worded question. Oh, because of pair. Okay. I had it right the first time. I wasn't reading the word pair. So it's not one pair. So that means two sides. There's two sides horizontal. So yeah, when this point is at 2, 2, it would be a parallelogram because there's one pair, so two sides, are horizontal, and then two sides are vertical. They were talking about pairs. There you go. Determine whether the statement is always, sometimes, or never true. If the slope of PQ is 1 over 4 and RS is negative 1 over 4, then this quadrilateral will be a parallelogram. So let's see. So PQRS. So if the slope of PQ is 1 over 4 and RS is negative 1 over 4, that wouldn't be possible. That could never be a parallelogram. This statement is never true. A parallelogram is a quadrilateral with two pairs of parallel sides, but if the slopes are not equal, then these sides are not parallel. Determine whether the statement is always, sometimes, or never true. If line M is parallel to line N, then the slope of line M is greater than 1. No. If line M is parallel to line N and the slope of line M is greater than 1, then the slope of line N is greater than 1. Yeah, parallel means same slope, so they have to be the same. This would have to always be true because they have the same slope. Therefore, if the slope is greater than 1, then the other one has to also be greater than 1. Find the value of each variable. So if this is a parallelogram, not only are opposite sides parallel, they're also congruent. So 2x plus 2 would be equal to 4, and then 3y would be equal to 6. So minus 2 minus 2, 2x equals 2. Divide by 2, x equals 1. Over here is just divide by 3, so y equals 2. X is 1, y is 2. Find the coordinates of the vertices of Q, R, S, T. So here they already have it plotted. So Q is at negative 5, 1. R is at negative 3, 2. S is at 0, negative 4. And T is at negative 2, negative 5. So use slope formula to find the slope of each side. The slope of QR. Okay. So QR, Q is at negative 5, 1. R is at negative 3, 2. So M is equal to 1 minus 2 over negative 5 plus 3. So M is equal to negative 1 over negative 2. So it's 1/2. It's 1 over 2. The slope of RS. So let's see, R is still at negative 3, 2. And S is at 0, negative 4. So the slope is 2 plus 4 over negative 3 minus 0. So the slope is 6 over negative 3. So the slope is negative 2. And just to save time, I would get the same thing with ST and with TQ. So now they want us to compare the slopes. The slope of QR times the slope of RS. So QR is 1/2, RS is negative 2, so that gives us negative 1. The slope of RS times the slope of ST. Same thing, negative 1, negative 1. That just means that these are negative reciprocals. So this is showing us that not only are opposite sides parallel, but that consecutive sides are perpendicular when they multiply and give you negative 1. So consecutive sides are perpendicular. The product of the slopes is negative 1. So this is a rectangle because it is a quadrilateral with 4 right angles. Determine whether the quadrilateral with the given vertices is a parallelogram. If so, determine whether it's a rhombus, rectangle, or neither, and justify your conclusions. Drag and drop each number or fraction into the correct box to determine the slope. Okay, so the slope of AB. A is at -5, -2. B is at -1, 0. So the slope is -2 minus 0 over -5 plus 1. So the slope is -2 over -4. So the slope is 1/2. Okay, so the first one's 1/2. BC. We'll keep B the same. C would be at C would be at 0, -2. So 0 plus 2 over -1 minus 0 is 2 over -1, which is -2. -2. So BC is -2. CD. CD, so that's 0, -2 over -4, -4. So the slope of that one is going to be -2 plus 4 over 0 plus 4. So that slope is going to be 2 over 4, which is 1/2. And then DA would be -4, -4, -5, -2. So the slope is -4 plus 2 over -4 plus 5. So that's -2, -4 plus 5. So that's -2 over 1, which is -2. -2. So that part is correct. So opposite sides of the quadrilateral have the same slope. So this is a parallelogram with both opposite sides are parallel. The product of the slopes of the consecutive sides is -1. So the consecutive sides are perpendicular. Therefore, this is a rectangle. Enter the slopes of AC and BD. So these are the diagonals. We're checking the diagonals, the slope of the diagonals. So AC, -5, -2, 0, -2. So the slope here would be -2 plus 2 over -5 minus 0. So that's 0 over -5. So the slope is 0. AC has a 0 slope, and then BD -1, 0, -4, -4. So the slope here is 0 plus 4 over -1 plus 4. So that's going to be 4 over 3. 4 over 3. So the product of the slopes of the diagonals is not -1. So the diagonals are not perpendicular. So this is not a rhombus. So this is a parallelogram and a rectangle, but not a rhombus. And that's correct. Complete the explanation to determine whether the following statement is always, sometimes, or never true. Consecutive sides of a if quadrilateral ABCD is a rectangle, then the slope of AB and the slope of AB is positive, then the slope of BC is negative. So let's see, there's a rectangle A, B, C, D. If this has a positive slope, that means it should have a negative, positive, and negative. That's the way, because they're perpendicular. So if AB is positive, then BC should be negative. That's gonna. So consecutive sides are perpendicular. So the product is -1. So if one side of a rectangle has a positive slope, then the other one has to have a negative, and this is always true. Complete the explanation to determine whether this is always, sometimes, or never true. If a quadrilateral is a rhombus and one diagonal has a slope of 3, then the other diagonal has a slope of The diagonals of a rhombus are perpendicular, so the product of the slopes is -1. Therefore, the diagonals of a rhombus cannot be 3 1/3, because when you multiply them, that gives you +1, not -1. So this is never true.